I'm gonna rewrite it. Okay, so this one looks really ugly, guys. We have a bunch of stuff, binomials as denominators. So, do any of you have an idea of how to eliminate these denominators? What can we multiply the entire equation by in order for us to eliminate this?
2?
You think 2 would work? 2 would cancel x?
No.
No, so
But
something that's gonna cancel x.
The x's.
The x's, and what else? We need to cancel that. So what can we be multiplied by to cancel this? This part, this one. So with this x, we can cancel those two x's. How about this ones? We multiply by x minus 2. The same thing. Okay, so this is what's going to happen. So here we're gonna have, so again, we're gonna multiply the whole equation. So we have x minus 2 on this side. So what are we doing with distributing this to these two terms? And with distributing this here. So for this part, we're gonna have x minus 2 times the 3x over the x minus 2. This is this term, this whole thing. And then minus, then this thing. Oh, should have wrote it in red. X minus 2 times this. You put it in parentheses. X plus 1, which is that, over x. And then this thing, I'm not going to distribute. You guys can tell that the x's will cancel and the x minus 2. So this cancels out, and you know this is cancels out. So you end up with 6. Now for these individual terms, so what can we cancel? We can put parentheses around it, and you guys can tell these two cancel out. So you're left with this. So x times 3x gives you 3x squared minus, you can tell that these x's cancel out, and you're left with this equals 6. So now it looks a lot more simpler like that than what it was originally. And that's how you think about it. So whatever you have, guys, if you ever see a question like this, whatever you have here, multiply it by that same thing. That would cancel everything on the bottom. Everything needs to cancel. If not, there's no point. Because if you keep one of these x's down here, you're gonna have trouble. So find something that would cancel everything. So now this one, let's continue here. So 3x squared minus, so this we would have to FOIL this part here. And I'm gonna put parentheses. Because whatever we get from here, it's gonna go here. So x times x would be x squared. X times 1 would be plus x. Negative 2 times x would be negative 2x. Negative 2 times positive 1 would be negative 2. So now combine like terms. Combine these two. So this would give you negative x. So positive x minus 2x gives you 1 negative x. Like that. Now we're going to distribute this negative into this parenthesis. That's why I put it in parentheses, because we have that negative. And you need to distribute that negative. It's going to change those signs. So 3x squared minus x squared plus x plus 2 equals 6. So 3x squared minus x squared would give us 2x squared So I combine these two terms. And then we have plus x plus 2 equals 6. So Michael Salcido, what else do we need to do to this equation? Because we need to solve for x. Remember, whenever you have an equation, more than likely you're going to solve for something. So we need this to be in a form, a specific one, in order to factor it.
Subtract the 6 on both sides?
Yes, sir. Thank you. So you need to leave it in this form where the 0 is on one side and then 2x squared plus x minus 4. Okay, this is where you would ask yourself, can I factor this? And I would probably try to factor it, but I can tell you right now you won't be able to. So when that happens, remember, when you're not able to factor, what's the last thing that we can do always? We can use the quadratic formula when you have this form. Everything needs to be on one side and the 0 on the other. You can either factor and solve like that. If you can't factor, then you would go to the quadratic formula. On that one side, so negative b plus minus square root of b squared minus 4ac over 2a. Okay, so a is equal to 2, b is equal to 1, and c equals to negative 4. I'm not going to solve this one. You guys should know. I'm just going to set it up and then I'll give you the answer. You guys simplify it. So negative 1 plus minus. So b would be 1 square minus 4 times 2 times 4 over 2a, which is 2 times 2. If you simplify this, the answer would, you would get an answer like this. Negative 1 plus minus. You will get a 33 here, and then a 4, and that would be the answer. Remember, plus minus means you have two different answers. And that's how you do this one. Okay, just to give you the setup, I'm not gonna solve it. So remember, this one, if you see a radical like that from the beginning, you need to use the square root property. So you need to bring this one, this x and that 6 to this side. So this becomes a 0, that becomes a 0. So you're left with minus x plus 6, and then you would divide by that negative, because we need to get rid of that negative. So this negative goes away. And I think you guys will recognize what happened. So negative, negative, so positive x, positive, negative, negative 6. This is, you guys should be able to solve from here. Just to ask you, David, no, Ruben, how can you solve this one? I'm not going to solve it, but if you were to solve this one, what would you have to do first?
Would you square both sides?
Yes, sir. So you guys know this process. You would square, and then you end up with x, this x, and you would end up with x minus 6 squared. Okay, when that happens, so you would have to expand this, bring this x to the other side, and make it look like this one here, where the 0 is on one side, and you have the equation on the other, and then you would try to factor to find the solutions. I think this one can be factored out. You guys want me to do it, or should I, or you guys get the idea of this one, Ruben? Or you want me to work it out?
I get the idea, sir.
Yeah, so expand this one with FOIL.
Well,
once you expand it, bring this x to this side also, equal it to 0, factor it out, and then solve for the x's. All right. Okay, this is the new stuff, and those of you that are taking calculus, you guys might have done this. Is someone here taking calculus?
I'm taking it, sir.
So I don't know. Have you guys done U substitution?
Yes, sir.
And then you know how to do this.
But I'm not good at it though.
No. So we can use U substitution in algebra too. This is how. So if you guys notice, this is a quadratic because that's a quadratic. It's a square. It's a quadratic equation, but it looks really ugly. Why? Because of this. That makes it ugly. So instead of trying to work through this, we can use the method, use substitution method. And everyone should pay attention because you guys need to know this. I'm gonna do those 4 and 5 and I'm done. So you're gonna have to make a statement here. And this is related to calculus. So if you ever take calculus, you're gonna use the method. Not the math. The math here is easy, but you will use this method with more complicated math. So you would name this, let's say, y. So I'm going to say y is equal to these two things because they're the same. So y is equal to x minus 3. That's the statement that I'm making. So I'm just playing with the math. I'm manipulating math so that it's more simple for me. So instead of having all of this, I'm going to have y instead because I made the statement. Y squared, I can always come back and resubstitute. Instead of this again, I'm putting y. Minus 4 equals 0. So if you guys notice, now it looks really easy. From here, remember you guys, all you have to do is factor if you can. Which I think this one you can. So I use y, so I'm going to use y here. And then you need to find two factors that multiply to this and add to that one. I think it's going to be 4 and 1. This one has to be negative and that one has to be positive. Negative 4 times 1 gives you negative 4. Negative 4 plus 1 gives you negative 3. So we have factor now. You do the 0 property where this factor u equals to 0 and you get that factor and equals to 0 and then solve for y. Plus 4 plus 4, so y equals to 4 here. Minus 1, so y equals to negative 1 here. Okay. Using your instincts, your mathematical instincts. How are we going to use this statement here, this equation that I did here with those answers? What other step do you guys think I need to make to find the final answer? Because originally the equation had this. I changed it to this to make it easy on me. But this is not the answer. Look, I found the solutions for y, but I haven't found the solutions for x. So what can I do to y? Any of you? Use your mathematical instinct.
Would you put the x minus 3?
Yes, thank you, sir.
Sure.
So you will go back to this statement and come back and substitute the x minus 3. And equal it to whatever you got here. Because remember, y is equal to that. So you can always come back and resubstitute. And then solve for that. So plus 3. So x is equal to 7. Plus 3. And x is equal to 2. And those two are the actual answers. The x's. The original was an x, not a y. The y we just used to help us find the x. This is U substitution. You use something like this in calculus. But you have to do what? Integrals and derivatives? What is it that I forgot? I haven't done calculus in years. You forgot, Ruben?
I think a little bit, but like with what you pull out with the u or the y, you did like opposite, or what is it called? The antiderivative or something like that.
So derivatives, that's all I wanted to know.
Yeah, there you go, the derivatives, yeah.
Okay, the last example. So we're gonna use substitution again. But this time, remember, we need a square. Does this look like a square? Do we have a quadratic function equation here? This is 2/3, this is 1/3. So when this happens, you need to make it look like a quadratic function. So let me copy this first. Okay, so that one has a 1/3 here. That one has a 2/3. This exponent can be split into two things like this. So you can have the 1/3, and that 2 on top, I can go ahead and carry it and put it outside as an exponent. So I'm using the power to a power rule here. So I have the 1/3 being a power, and I elevate that to the 2 to another power. If you combine these two, they would equal that 2/3 again. So I did not change this. I just made it look different. It just looks different, but it's the same thing. So now, if you guys notice, let's make our statements. And this time I'm gonna name it M. So M is equal to what, guys? What can I equal it so that I simplify this quadratic equation? M equals to what, Michael Salcido? So look for something that it's the same in this equation. What looks the same, Michael? So M is gonna equal what?
1/3.
Not just 1/3, but x to the 1/3. So instead of x to the 1/3, I'm gonna use M, because x to the 1/3 it would make things very difficult. So I'm gonna use M instead. So this whole thing is M. So I just have the 2 here, minus 5m, because the whole thing is M, this whole thing, plus the 6 equals 0. So now I made it look really easy. So again, you factor out. This would be, so we use M. And this is 3 times 2. Both of them has to be negative. Negative times a negative gives you that positive 6. Negative plus another negative gives you that negative 5. And you add them. So again, you do the same. You split them. And then you solve for M. And what's the last step? Let me see who was paying attention. Angelina, what's the last step here? Angelina. So looking back to the statement that we made here, how can we find the real answer? Because the equation, the original, has an x. Right now we found M, but M is not the x yet. What can we use to find the answer? What do I have to do to the M, Angelina? Or text or chat to me? No, Angelina no quiere. How about you, Hannah Diaz? Or Jerry. I know you know this. Jerry, what do we need to do to the M? This is the last example, Jerry. Me voy a dormir. Jerry. All right. Yes. So we're gonna make the M. We're gonna resubstitute the x to the 1/3. Okay. And then this, I'm gonna make it look different. I'm gonna do the cube root of x. These two are the same thing. The cube root of x. So who else is here? Juan, you there, Juan? Anaya. Ariana. ¿Están todos dormidos, Ruben?
Yes.
So we reached this step. How can we solve for x from here? So this is a cube root. Cube root of x. So in order to solve for x, we need to get rid of that radical. How can we get rid of this radical? So we have to elevate this to one number to get rid of the radical. So the index is 3. We need to elevate to what power?
1.
No, 3. It needs to be the same so that this cancels out. This cancels out. 3 cubed gives you 27. 2 cubed gives you 8. And those are the answers. So 2 cubed means 2 times 2 times 2, guys. 3 cubed means 3 times 3 times 3. And that's how you use substitution. And that's it, guys. Let me turn the video off.